Today I'm going to be working on a 2013 Chevy Malibu. I'm going to be testing the AUT sensor to see if it has a dual or single range thermistor. Right now the vehicle has just been turned on with an operating temperature of 82 degrees. The way I have this test set up is I have back probe the sensor wire and set up a ground for me to be able to get the voltage, and as the temperature increases the voltage should drop. And if it is a dual range, once it reaches about 1 volt or like less than 1 volt, it should switch over back to 3 volts. If it doesn't, that means this is a single range thermistor, which is completely fine, but we're just going to watch that. As we get close to the 1 volt line, this is where it would be shooting back up to either 4 or 3 volts, just so we know that the dual range would kick in, and we're about to see if it possibly has one or not. It most likely would have kicked in by now, and since it didn't, this car has a single range thermistor. I'm just gonna let it go down a little bit longer as it reaches a higher operating temperature. Here I have a wiring diagram pulled up for the ECT sensor and also the IAT sensor. The intake air temperature sensor is built into the mass airflow sensor, so we'll find that for you guys real quick. But for the ECT sensor, the wires are blue and gray. And here we find the intake air temperature sensor. The first sensor I ended up finding was the EC10 sensor, which we can verify those are blue and gray wires from the wiring diagram. Now I'm heading over to the mass airflow sensor, which is has the built-in intake air temperature sensor. I have them both unplugged right now so that we can read the PIDs. They're both reading -40. After plugging them back in, this is their normal operating temperature. Right here, I ended up shorting the wires together to see if it would give me a interesting reading or shoot me a code. It ended up giving me a reading of 302 degrees, and it did send in a couple of codes, which was only a one-trip fault. It ended up setting off the light, and the
All right, so now we're going to test the throttle position sensor on this 1999 Jeep Grand Cherokee. As you can see, Landon has his multimeter hooked up to these two pins on the throttle position sensor, and they're hooked up to his multimeter leads. And as you can see, at a closed throttle, we got about 0.76, ohms. And then as he presses the throttle plate down,
That's KO.
Oh, KO. So what is that? Kilo ohms? Yeah, kilo ohms. And then as he presses down the throttle plate, see how the resistance increases. as the throttle position sensor does its full sweep until we reach, let's see what it reaches as a maximum here. About 4.26 kilo ohms is our maximum reading.
All right, so right now we are pinned into to pin 1 and pin 3 on the TP sensor, which is just the 5-volt reference and the sensor ground. If you take a look here, we have 5.3 k ohms through the entire resistor tape that the signal arm is dragging on. And if you take a look here, so pin 3, if you come through, it is all spliced together with the rest of the sensor grounds, and they go directly to the PCM via return wire. And then our signal wire, we can just trace it back up. It goes north and then takes a left right here, and then you can see that is our TP sensor signal wire. And then coming back here, pin 1, that is our 5-volt reference, and that is spliced into the other reference, or the 5-volt power supplies to the rest of the sensors. That also comes up north and then takes a left right here, and then goes to the PCM as a 5-volt reference.
Go.
So right now we have a lot of stuff hooked up. So we have a multimeter hooked into the signal wire, and then we have our multimeter hooked up to ground. So we're getting a voltage reading of the signal wire and ground, and then we also have our Pico hooked up to the battery ground and also the signal wire. So we have that pulled up right now. We got it running about 5 seconds per division on a 5-volt scale. And so what I'll do is I'm going to do a sweep test, and so you can see as I slowly go up and open the throttle, voltage does increase. And then we can do this to check for bad spots, like bad connections or anything like that on the resistor tape or the signal wire. Right now, I'm at wide open throttle. You can see it settle out. And then if you come over here and look at the voltmeter, it kind of mirrors that, but in a digital form, you can see that we're getting roughly 4.021 constant voltage. And then, as you can see, as I let the throttle go back down or close, voltage will go back down, and that is mirrored on the picoscope too on the graph. So you can kind of get a good reading of graph, and you can see it on your voltmeter. That's kind of how voltage acts on the signal wire while the throttle